In few of our upcoming videos, we'll be uploading limits. Limits are essential and building blocks of calculus and mathematical analysis in general, and are used to define continuity, differentiability and integrability of a function. Limits किसी भी बोर्ड एग्जामिनेशन या कोई भी अंडरग्रेजुएट कोर्स का डेफिनेटली कुछ न कुछ हिस्सा या पोर्शन कवर करता है. So, going by the essentiality of the subject, we have decided to upload a few on the limits. Since a whole lot of examples are covered by the differential calculus by Azim, Chopra and Kotter, so we'll be consulting that very book for our reference. In addition, one can also consult differential calculus by Professor N.B. Bali. Now, limit is a unique value which a function or a sequence approaches in its codomain set when the input or the index approaches a particular value in its domain set. Or equivalently, we can say the change which the function attains in its codomain set when there is a change in its domain set. If fx is a function defined over a domain D and A is any point within its domain, then limit of the function fx at x is equal to a will be defined as limit x tends to a f of x is equal to f of b, which essentially means two things. Number first, left hand side में जो limit है ये exist करता हो, and number second, it equals f of a. And if f of x is a function which has breaks in its graph at a supposed point a, then at that very point we compute the left hand limit and right hand limit, and if that also equals value of the function at that point, then limit of the function is defined. That is at point a we compute left hand limit, right hand limit and value of the function. Thus, we'll have limit x tends to a from the left f of x is equal to limit x tends to a from the right f of x is equal to f of a. अगर ये तीनों चीज़ें बराबर हो, then limit of the function exists, and if any one of these is unequal, then we can say limit of the function at that point does not exist. Now, limits are essentially computed in two senses. Number first, we compute limit at a finite number a, and number second, we compute limits at infinity as well. So, we compute limit at a finite point, limit at a point which obviously is a finite point, and number second, we do compute limits at infinity. In both of the cases, चाहे हम limit at a point या limit at infinity निकाल रहे हो, we compute limits of all these functions. We compute limits of algebraic functions or polynomial functions. We do compute limits of the rational functions. Rational functions यहाँ पे एक most important case है, and it is the most common type here. And then we compute limits of the trigonometric functions, and we compute limits of the exponential functions. Or in all, it may be combination of all these functions. It may be product of all these functions. So we'll start with limits of the polynomial functions, and first things first, we'll firstly compute the limit at a single point or a finite point, and then we'll move on to limits of the polynomial functions at infinity. If fx is a polynomial of degree n in this form, say fx is equal to a suffix n x to the power n a n minus 1 x to the power n minus 1 up to a1x plus a naught, obviously with the condition that the leading coefficient an has to be non-zero, then limit of this polynomial function will be limit x tends to a f of x is equal to f of a. So, इस polynomial function का limit simply it will be value of the function at that very point. जिस point पे हम limit compute करते हैं उसी point पे इस function का value, that will be the limiting value in this case. as an example, if we have f of x is equal to 2x square plus 5, so इस polynomial function का हमें limit निकालना हो at x is equal to 2, then limit of this function fx at x is equal to 2 will be simply f of 2, that is limit x tends to 2 f of x, so it will be limit x tends to 2x square plus 5, so it will be 13, which is again equal to f of 2. Now limit of a polynomial function at infinity, कोई भी polynomial अगर हमारे पास हो और हमें उसका limit निकालना हो but at infinity, obviously it has to be a non-constant polynomial, क्योंकि कोई भी constant polynomial होगी तो उसका limiting value वही होगा, चाहे हम limit at infinity निकाल रहे हो चाहे limit at a point निकाल रहे हो. So it has to be a non-constant polynomial. We have the simplest example से या simplest polynomial से हम शुरू करेंगे. If we have fx is in this form, fx is equal to x, और इस linear function का हमें limit निकालना हो at infinity, then it will be limit x tends to infinity f of x is equal to limit x tends to infinity of x. So अगर x अब infinity को जा रहा है, so obviously it will be the infinity. So limit of this linear polynomial function will be infinity. Now if we have number second fx is in this form, x plus any constant, say 5 is any constant, then इस polynomial का भी अगर हमें limit निकालना हो, so it will be limit x tends to infinity f of x, which will be again limit x tends to infinity x plus 5. Obviously limit of sum is sum of limits, so it will be infinity plus 5, which will be again infinity. Again, if we have limit x tends to infinity x square, then it will be obviously infinity square, which will be again infinity, which means limit x tends to infinity x square plus 5 or any other constant is again infinity. So if we proceed likewise, we can say limit of any polynomial function at infinity will be infinity. Now number second, limit of the rational function. Say if we have a rational function of the form fx divided by gx, define it over a domain D such that gx is not equal to 0 in its domain of definition, then limit of this rational function can be again computed in two senses. Number first, we'll be computing its limit at a particular point, and then we can also compute its limit at infinity. So number first, limit at a point. Limit at a point, say a. Say we have to compute its limit at a particular point in its domain of definition, which is a. Say if fx divided by gx is any rational function, और हमें इस rational function का limit निकालना हो at a particular point, limit x tends to a. Then we have three different cases here. While computing limit of this function, we have three different cases here. Case first, so if at x is equal to a, f of a is not equal to 0 and g of a is not equal to 0. So case first में अगर at x is equal to a, fx at x is equal to a and gx at x is equal to a 0 के बराबर ना हो, then limit of this rational function fx divided by gx will be f of a divided by g of a, because from the previous slide we know limit x tends to a, f of x is equal to f of a. Case second, if at x is equal to a, f of x 0 के बराबर हो but g of x is not equal to 0, that is f of x equals 0 and g of x is not equal to 0, then limit of this function, then limit x tends to a, f of x divided by g of x is equal to 0. केस थर्ड, इफ एट x इज इक्वल टू a f ऑफ a 0 के बराबर ना हो बट इंस्टेड g ऑफ a इज इक्वल टू 0, दैट इज f ऑफ a इज नॉट इक्वल टू 0 एंड g ऑफ a इज इक्वल टू 0, देन अगर हम ये डिनोमिनेटर में से 0 निकाल सकते हैं बाय सम suitable procedures, then limit of the function will exist, otherwise limit of the function turns out to be undefined. And case fourth, if f of a is equal to 0 and g of a is also 0, which means limit x tends to a, f of x divided by g of x is of the form 0 by 0, then this is called an indeterminate form. Now limit of the rational function at infinity, if we have to compute limit of the function fx divided by gx at infinity, then in this form also we'll have three different cases. Number first, if degree of fx is less than degree of gx, number first, number second, case second, so it will be case second में if degree of fx equals degree of gx, and in third case we can have degree of fx is greater than degree of gx. so ये तीनों cases exist कर सकते हैं. so in तीनों ही cases में we can have degree of numerator greater than degree of denominator, degree of numerator equals degree of denominator, or we can have degree of numerator is less than degree of denominator. एंड तीनों ही केसेस में जब हम लिमिट्स कंप्यूट करते हो तो लिमिट कंप्यूट करने के लिए वी ऑलवेज डिवाइड बाय द हाईएस्ट पावर टर्म इन द न्यूमरेटर और द डिनोमिनेटर. न्यूमरेटर और डिनोमिनेटर में भी जो भी हाईएस्ट पावर टर्म है हम उस टर्म से डिवाइड करेंगे दोनों न्यूमरेटर एंड डिनोमिनेटर को. नाउ तीनों ही केसेस को हम वन बाय वन डिस्कस करते हैं. केस फर्स्ट, इफ वी हैव लिमिट x अप्रोचेस टू इन्फिनिटी f ऑफ x डिवाइडेड बाय g ऑफ x, and if fx is in this form a1 x to the power m, a2 x to the power m minus 2 plus up to a0, and gx इस फॉर्म में है b1 x to the power n, b2 x to the power n minus 2 plus up to b0 here. So m is greater than n, that means degree of numerator is greater than the degree of denominator. So इस केस में भी हम highest power term, so highest power term यहाँ पे x raised to power m because m is greater than n. So highest power term x raised to power m से हम numerator and denominator को divide करेंगे. So this will be limit x approaches to infinity a1 x to the power m divided by x raised to power m plus a2 x to the power m minus 1 divided by x to the power m plus up to a1 x to the power 1 divided by x raised to power m plus a0 divided by x raised to power m divided by b1 x to the power n divided by x to the power m plus b2 x to the power n minus 2 divided by x to the power m plus up to b1 x to the power 1 divided by x raised to power m plus b0 divided by x to the power m. So यहाँ से x to the power and x to the power m कट जाएगा, so it will be limit x approaches to infinity, so it will be a1 plus यहाँ से x to the power m, x raised to power m minus 1, so it will be a2 divided by x raised to power 1 plus likewise we will have a3 divided by x to the power 2 plus up to a0 divided by x to the power m. This will be b1 divided by x to the power m minus n plus b2 divided by x to the power m minus n plus 1 plus up to b0 divided by x to the power m. And if we distribute the limits, because we know limit of the quotient is quotient of the limits, and then limit of sum is sum of limits, so it will be a0 ए नॉट प्लस a2 divided by x1 यानी a2 divided by infinity which will be 0, a3 divided by infinity 0, 0, this will be again 0, 0, 0, so this whole thing will be 0, so it will be a1 plus 0 plus up to 0 divided by 0, so a1 divided by 0, so this will be infinity. So limit in this case when the degree of the numerator is greater than the degree of denominator will be infinity. Now case second, if we had to compute limit of this rational function at infinity such that degree of the numerator and degree of the denominator is same, then we can write limit x tends to infinity, again highest power term which will be x to the power m or x to the power n, इससे हम divide करेंगे, so it will be a1 x to the power m divided by x to the power m plus a2 x to the power m minus 1 divided by x to the power m plus up to a1 x to the power 1 divided by x to the power m plus a naught divided by x to the power m divided by b1 x to the power n divided by x to the power m x to the power n x to the power n क्योंकि m और n same है plus b2 x to the power n minus 1 divided by x raised to power n plus up to p naught divided by x raised to power n, and this will be limit x tends to infinity, it will be a1 plus a2 divided by x raised to power m में से x raised to power m कट जाएगा, so it will be x plus up to a naught divided by x to the power m divided by x raised power n, and x raised power n कट जाएगा, so it will be b1 plus b2 divided by x plus up to b naught divided by x to the power n, and again अगर हम लिमिट डिस्ट्रीब्यूट करें न्यूमरेटर एंड डिनोमिनेटर को, then we know limit of the sum is sum of the limits, so it will be a1 limit of the constant will be a1, इसका भी b1, so it will be a1 divided by b1, a2 divided by x, it will be a2 divided by infinity, any non-zero constant divided by infinity, it will be always 0, so it will be a1 divided by b1 plus 0 plus 0 plus 0, so it will be only a1 divided by b1, which means in case when we have degree of numerator equaling degree of denominator, the value of the determinant will be leading coefficient of the numerator divided by leading coefficient of the denominator. Now case third, when degree of the numerator is less than degree of the denominator, say if we have limit x tends to infinity fx divided by gx in this form such that degree of numerator m is less than degree of denominator which is m, which means m is less than n. Again we will divide by the highest power term. Here the highest power term is x to the power m, so we'll divide numerator and denominator by x raised power m, so it will be limit x tends to infinity a1 x to the power m divided by x raised to power n plus a2 x to the power m minus 1 divided by x raised to power n plus a1 x to the power 1 divided by x raised to power n plus a naught divided by x raised to power n divided by b1 divided by x to the power n divided by x to the power n plus b2 x to the power n minus 1 divided by x to the power n plus up to b1x divided by x raised to power n plus b naught divided by x to the power n. Here n is greater than m, so it will be limit x tends to infinity a1 divided by x to the power n minus m plus a2 divided by x to the power n minus m plus 1 plus up to a1 divided by x to the power n minus 1 plus a naught divided by x raised to power n whole divided by b1 x raised power n से x raised power n कट जाएगा, so it will plus b2 divided by x plus b3 divided by x square up to b0 divided by x to the power m. So अब अगर limiting value use करें, so this will be 0 0 0, this whole expression will be 0 divided by b1 plus 0 0 0, so this will be b1 plus 0, so 0 divided by b1, so it will be 0. So to conclude, we have three different cases when degree of numerator is greater than degree of denominator. In this case, limit of the rational function will be infinity, and if we have degree of numerator equaling degree of denominator, in this case the limiting value of the rational function will be leading coefficient of numerator divided by leading coefficient of denominator. And when we have degree of numerator is less than degree of denominator, in this case limiting value of the rational function will be 0.